What if your body had a built-in system capable of dismantling damaged cells, recycling biological waste, and potentially slowing down the aging process? And almost nobody is using it correctly. This isn't science fiction. It's a process that won Nobel Prize in Physiology or Medicine in 2016, and researchers have been studying its effects on human health ever since. The question isn't whether autophagy works. The question is, what actually happens when you trigger it every single day for 30 days straight? Most people think fasting is just about not eating, but what's happening at the cellular level is far more complex than skipping a meal. When your body detects a drop in nutrients, specifically when insulin levels fall and cellular energy sensors like AMPK get activated, it flips a biological switch. That switch tells your cells to stop growing and start cleaning. That's autophagy. The word itself comes from the Greek, auto meaning self, and phagein meaning to eat, literally self-eating. But don't let that word scare you. This is one of the most protective things your cells can do. Instead of destroying healthy tissue, autophagy targets the damaged proteins, dysfunctional mitochondria, and cellular debris that accumulate over time and contribute to disease. Think of it as your body's internal recycling plant, finally getting permission to run. What triggers it? The research points to a few consistent activators: fasting, caloric restriction, exercise, particularly endurance training, and compounds like spermidine and rapamycin, which have been studied in laboratory settings. A 2010 paper published in Nature by Dr. Beth Levine and colleagues showed that autophagy induction through these pathways has measurable effects on cellular health and longevity markers. The mechanism is real, it's documented, and understanding how to activate it changes how you think about hunger entirely. Here's what most videos won't tell you up front. The effects of daily autophagy activation aren't linear. The first week feels different from week 3, and week 3 feels different from day 30. Your body adapts, adjusts, and responds in layers. And that's exactly why a 30-day window is so interesting to examine scientifically. In the early days, the most immediate cellular response involves the clearance of short-lived damaged proteins and organelles. Studies using animal models have shown that even 24 hours of fasting can significantly upregulate autophagy markers like LC32 and Beclin-1 in liver and muscle tissue. In humans, research from the University of Southern California, including work by Dr. Walter Longo on prolonged fasting protocols, demonstrated measurable changes in cellular regeneration pathways after just a few days of caloric restriction. By the end of week 2, something more significant starts happening. Mitochondrial quality begins to improve through a sub-process called mitophagy, the selective removal of dysfunctional mitochondria. This matters more than most people realize, because mitochondrial dysfunction is directly linked to metabolic disease, neurodegeneration, and accelerated aging. A 2019 review in Cell Metabolism highlighted that regular activation of mitophagy pathways correlates with improved metabolic flexibility and reduced inflammatory markers. By day 30, if the protocol is maintained consistently, the cumulative effect on cellular quality is not trivial, and you'll understand exactly what that means before this video ends. When people think about disease prevention through diet, they usually think about cholesterol, blood sugar, or inflammation in a general sense. Very few people connect what they eat, or when they stop eating, to conditions like Parkinson's disease, type 2 diabetes, or even certain types of cancer. But the science connecting autophagy to all of these is not speculative. It's published, peer-reviewed, and growing every year. Take type 2 diabetes. One of the core problems in metabolic disease is the accumulation of damaged beta cells in the pancreas, the cells responsible for producing insulin. Research published in Cell by Dr. Masaki Komatsu's group showed that impaired autophagy in pancreatic beta cells directly contributes to their dysfunction and death. When autophagy is working properly, those damaged cells get recycled before they cause problems. When it's not, they pile up, insulin production suffers, and blood sugar regulation starts to break down. This isn't a minor detail, it's a foundational mechanism in one of the most prevalent diseases on the planet. Cancer is more complex because autophagy plays a dual role depending on the stage of the disease. In healthy cells, autophagy acts as a tumor suppressor, removing the kind of cellular damage that can lead to malignant transformation. A landmark study in Nature showed that mice with reduced Beclin-1 expression, a key autophagy protein, developed tumors at significantly higher rates. The relationship isn't simple, and researchers are careful to distinguish between prevention and treatment contexts. But the baseline message is clear. A body where autophagy runs consistently is a body with significantly better cellular surveillance against the kind of damage that precedes disease. The brain is one of the most metabolically active organs in the human body, and it's also one of the most vulnerable to the accumulation of damaged proteins. Alzheimer's disease, for example, is characterized by the buildup of amyloid beta plaques and tangles, precisely the kind of misfolded protein aggregates that autophagy is designed to clear. The connection between autophagy, dysfunction, and neurodegeneration isn't a hypothesis anymore. It's one of the most active areas of research in modern neuroscience. Dr. Ralph Nixon at NYU's Center for Dementia Research has published extensively on the role of lysosomal dysfunction, the cellular machinery that executes autophagy, in Alzheimer's pathology. His work shows that in Alzheimer's patients, autophagic vacuoles filled with undigested material accumulate inside neurons years before clinical symptoms appear. This means the cleaning system breaks down long before the disease becomes visible. And it raises a provocative question. Could consistently activating autophagy throughout life delay or reduce the severity of neurodegenerative disease? The early evidence, while not yet conclusive in humans, points toward yes. Beyond disease prevention, autophagy in the brain also connects to cognitive performance in healthy individuals. A 2021 study in Nature Aging found that enhancing autophagy in aged mice not only reduced protein aggregates, but also restored synaptic plasticity, the brain's ability to form and strengthen connections. The mice performed significantly better on memory tasks. Now, you're not a mouse, and translating animal data to humans requires caution, but the mechanistic logic is sound, and clinical researchers are actively investigating autophagy-enhancing interventions for cognitive health. Something worth paying attention to, especially in a world where cognitive decline is increasingly common. There's a lot of noise online about what triggers autophagy. Some people claim that a single cup of black coffee activates it. Others say you need to fast for 72 hours. The reality sits somewhere in between, and it depends heavily on the specific pathway you're targeting, your metabolic state, and how consistently you apply the protocol. Let's go through what the actual research supports. Intermittent fasting, specifically the 16-8 protocol, where you eat within an 8-hour window and fast for 16, is the most studied and most accessible method. A 2019 clinical study published in Cell Metabolism by Dr. Krista Varadi's team showed measurable improvements in autophagy markers, along with reductions in blood pressure, oxidative stress, and insulin resistance in subjects following a time-restricted eating protocol for just 12 weeks. You don't need extreme fasting to see results. Consistency matters more than duration, at least in the early stages. And speaking of consistency, what happens when you do this every day for 30 days is something most people underestimate completely. You'll see exactly what by the end of this video. Exercise is the other major lever, and it's often underestimated in this conversation. Endurance exercise, running, cycling, swimming, activates AMPK and inhibits mTOR, the two main regulatory switches for autophagy. A study published in Nature in 2012 by he and colleagues demonstrated that exercise-induced autophagy in muscle and liver tissue plays a direct role in metabolic regulation and glucose homeostasis. Resistance training also contributes, though through slightly different pathways. The practical takeaway: combining a fasting window with regular exercise creates a compounding effect on autophagy activation that neither strategy achieves alone. That combination, sustained for 30 days, is where things get genuinely interesting. There's a concept in cellular biology called proteotoxic stress, the damage caused by the accumulation of misfolded or aggregated proteins inside your cells. Over time, this cellular garbage builds up, interferes with normal function, and creates the kind of internal environment where diseases like Alzheimer's, Parkinson's, and even cancer find fertile ground to develop. Autophagy is, quite literally, the only known endogenous mechanism your body has to systematically remove this buildup. Dr. Ana Maria Cuervo, one of the world's leading researchers on autophagy at the Albert Einstein College of Medicine, has spent decades studying what she calls chaperone-mediated autophagy, a specific pathway that declines with age. Her research shows that as we get older, this cleaning system becomes less efficient, and the proteins that should be degraded start to accumulate instead. In simple terms, the older you get, the more you need autophagy, and the worse your body gets at doing it on its own. That asymmetry is a big part of why aging accelerates. The practical implication here is significant. Triggering autophagy consistently, through fasting windows, exercise, or dietary strategies, essentially forces this cleaning mechanism to stay active even as age tries to shut it down. A 2018 study published in Autophagy Journal found that regular intermittent fasting in middle-aged subjects led to measurable reductions in P62, a protein that accumulates when autophagy is impaired. Less P62 means the system is working, and a system that keeps working is a body that keeps functioning at a higher level. Here's where most people following fasting protocols quietly sabotage their own results. They do everything right. Skip breakfast, drink water, maybe exercise in the morning. And then they add something small that they assume is harmless. A splash of cream in their coffee, a handful of almonds, a just 10 calories protein shake. And just like that, autophagy stops. Not slows down, stops. The reason is mTOR, mechanistic target of rapamycin, the master growth signaling pathway that autophagy competes with directly. When mTOR gets activated, autophagy gets suppressed, and mTOR responds to remarkably small amounts of certain inputs, particularly amino acids and insulin-spiking carbohydrates. A 2014 study in Molecular Cell showed that even low concentrations of leucine, an amino acid found in dairy and most protein sources, are sufficient to activate mTOR signaling and suppress autophagic flux. That means anything with significant protein content during your fasting window is likely ending the process you're trying to sustain. What doesn't break it? Plain water, black coffee, and plain tea appear to be safe based on current evidence. And some research actually suggests that coffee's polyphenols may weakly enhance autophagy through AMPK activation. A study published in Cell Cycle found that caffeine itself has autophagy-inducing properties in certain cell types. But the margin for error is small, and the honest answer is that less is more during your fasting window. If you're going to commit to 30 days of daily autophagy activation, getting this detail right is the difference between doing it and just thinking you're doing it. This is a good moment to pause and think about your own routine. Do you fast regularly? Have you ever noticed changes in energy, mental clarity, or hunger patterns during fasting windows? Drop a comment below. I read every single one, and your experience might help someone else watching this right now. Every powerful biological mechanism has a context where it helps and a context where it causes harm. Autophagy is no different. The research supporting its benefits is strong, but the research also shows that chronic, aggressive autophagy activation without proper nutritional support can create problems that most people in the fasting community simply don't discuss. The most documented concern is muscle protein degradation. When autophagy runs too aggressively, particularly in the context of very prolonged fasting combined with low protein intake, it can begin breaking down skeletal muscle tissue for energy. A review in Aging Research Reviews noted that while short-term autophagy induction is protective, chronic caloric restriction without adequate protein cycling can accelerate sarcopenia, the age-related loss of muscle mass. This matters especially for people over 40, where muscle preservation becomes increasingly critical for metabolic health and longevity. Triggering autophagy every day doesn't mean starving yourself every day. The eating window matters as much as the fasting window. There's also an important caveat for people with specific medical conditions. Individuals with type 1 diabetes, eating disorder history, adrenal dysfunction, or those who are pregnant should not follow aggressive fasting protocols without direct medical supervision. Autophagy research is largely conducted in controlled settings with healthy subjects, and extrapolating those results to clinical populations requires caution. The goal of understanding this science is to use it intelligently, not to turn a beneficial mechanism into an obsession. 30 days of smart, consistent activation looks very different from 30 days of extremes. By the time you reach day 30 of consistent autophagy activation, through daily fasting windows combined with regular exercise, the changes happening inside your body are no longer just acute cellular responses. They've become systemic adaptations. Your mitochondria are cleaner and more efficient. Your inflammatory baseline has shifted. Your insulin sensitivity has measurably improved. These aren't claims. They're the cumulative result of the mechanisms we've been walking through this entire video. A 2020 clinical trial published in Cell Reports Medicine followed subjects through a structured intermittent fasting protocol and found that after 4 weeks, participants showed significant reductions in visceral fat, improvements in cardiometabolic markers, and reductions in circulating inflammatory cytokines like IL-6 and TNF-alpha. Those markers don't change overnight. They change because the cellular environment has been consistently maintained in a state that favors repair over accumulation. 30 days is enough time for that shift to become measurable in blood panels. Perhaps the most underappreciated effect is what happens to your relationship with hunger itself. Research from Dr. Mark Mattson's lab at the National Institute on Aging showed that consistent fasting reprograms hypothalamic signaling over time, changing how the brain interprets hunger signals and how it regulates appetite hormones like ghrelin and leptin. People who maintain a fasting practice for 30 days or more consistently report that hunger becomes more manageable, energy more stable, and mental clarity sharper during fasting windows. That's not willpower. That's neurobiology adapting to a consistent stimulus. And once your brain adapts, maintaining the practice stops feeling like discipline and starts feeling like you're normal. After everything we've covered, the most important question becomes practical. How do you actually build this into your life without turning it into a full-time obsession or swinging into extremes? The answer, based on what the research supports, is surprisingly accessible, and it starts with understanding that you don't need to do anything radical. A daily 16-8 fasting window, finishing dinner by 8 at night and not eating again until noon the next day, is enough to consistently activate autophagy in most healthy adults, according to multiple clinical studies, including work from Dr. Sachin Panda's circadian biology research at the Salk Institute. Pair that with 3 to 4 sessions of moderate to vigorous exercise per week. Prioritize protein adequacy during your eating window to protect muscle mass, and you have a protocol that is both evidence-based and sustainable. No supplements required at the baseline level. No extreme restriction, just consistency. The 30-day framing matters because it takes approximately that long for the adaptations to compound into something you can feel and measure. The first week is adjustment. The second week is the cellular machinery catching up. By weeks 3 and 4, the metabolic and neurological adaptations start to stabilize into a new baseline. That's when people report the clearest cognitive function, the most stable energy, and the most significant changes in body composition. This isn't a detox trend. This is applied cell biology. And the difference between people who benefit from it and people who don't is almost always just consistency over time. If this video changed how you think about fasting, aging, or cellular health, hit the like button. It genuinely helps this content reach more people who need it. Subscribe if you want to keep going deep into the science of how your body actually works. And share this with someone who still thinks fasting is just about losing weight. Because now you know it goes much further than that.